right. Hi, everyone. Now, that's a full house. Oh, my God. All right, so let's have a little chat about how microservices changed the world of testing. This comes very well after the discussion yesterday we had with the deep dive into how unit testing is showing you ways to improve the design. This is a kind of a sequel. What happens if you want to write more integration tests? And we'll focus on the challenges that we face there. My name is Rentea. I'm a Java champion, coding for almost 2 decades. In the last 10 years, I spent consulting and teaching at various companies throughout Europe. My main topics are clean code architecture, unit testing. That's what I love to do. But of course, we can't do that without frameworks. So Spring, Hibernate, Reactive. And adults also have to face security and performance issues. So also that. You can find many of my talks on YouTube already. And what I'm really proud of is the community I founded several years ago, which has grown into the biggest community in the world on software crafting. Basically, people are passionate about writing simple, clean code with, let's say, sufficient degree of confidence in their tests. And we meet every month for 1 hour live on Zoom and then streamed on YouTube to talk about various things. It's completely free. Join if you want. And because there is life after work, 2 children, a cat, and a garden. Okay. So, the pyramid of testing. The pyramid of testing that tells us that up in the top of the pyramid we have the flows that go a long way through our code. The integration tests or the service tests are testing just several components together, while the unit tests are focusing on thin slices of behavior, on quirks, on details, on edge cases, let's say. Now, the higher you go, the more integration you have to face, the more moving parts are in play. The lower you go, the more narrow and simple the test would be, and also cheaper and faster and more, let's say, reproducible and safe. Of course, you want to exercise the checkout flow of an e-shop with an end-to-end test to prove that the checkout can really work. Now, there is something above the pyramid that's not displayed here, testing in production. Anyone does testing in production? Continuously trying to fire some requests to production? That's on top of the pyramid, right? Now, the overlapping is intentional. We will test the same features at different levels, and the pyramid tries to tell us that we should write more unit tests than those above. The pyramid, however, was designed in the times of the monolith, and they tried to push us to write more unit tests for the corners of our logic. Now, things are a bit different when you play microservices. A monolith has rather few endpoints under which there are a terrible amount of complexities. You can't possibly get everywhere from the API, so you need unit tests to get there, right? But with microservices, we get suddenly much more attack surfaces, much more stable APIs that are perfect for testing, right? And you should not have, I don't know, tens of thousands of combinations under a single API in a microservice. That's no longer a microservice, right? So, unfortunately, on the other side, microservices have to face another issue these days, the increasing amount of failures due to misconfiguration. I want you to tell me, how many of you are facing more issues due to bad config than because of bad logic implemented wrong? There you are. Now what? That's like 20%, 30% of you are facing a lot of configuration issues, right? How do we cover for those, right? So it's normal that the focus shifts towards testing the whole things with all the libraries in play, right? So it's normal that we will look at how to test the bubbles, the little services that we have. And please, let's welcome the honeycomb testing strategy. Again, I want to sit on the shoulder of giants here. It's not just me saying here, this is Spotify, right? So they're saying, hey, we have this integrated test. This is the same as the top of the pyramid. End-to-end flows going the whole way. We have the integration flows focusing on a single microservice, right? Trying to exercise as many passable paths through that API as possible. Of course, you can't, and you will fire many tests at the entry point, right? But you can't possibly go to all the quirks of a nasty algorithm. So every now and then you're gonna face some complexity. Now, this test at the integration level that you write, you want to keep isolated, to be reproducible. Therefore, you have to control all the connections to the outside world that microservice does. Therefore, Testcontainers and Wiremocks. I'm going to try to prove some of these techniques today in a brief live coding, but The idea is that you would avoid mocking. You would put all your code in play with all the config next to it, spin it off in a Spring Boot test or in a Docker, and connect it to other Dockers around to test the stuff. When you face some real complexity, that complexity will very often be naturally decoupled by itself. It's self-contained. It will shout out, I am the price calculation, and that will be decoupled and tested. You will have to do that because you can't possibly go 1,000 tests through the API level. So wherever there is a high degree of complexity in an algorithm, that deserves implementation detail tests, the former unit tests, if you want. Right? That's like an introduction. The topic today, however, so unit tests, they will focus on a narrow piece of behavior, right? They will test some classes or maybe one single class, trying to prove some logic. But bugs can still sleep, and I want to repeat the video I played yesterday. It's so fun. It's so fun when you see the unit testing working. Sorry, I need to repeat it. Unit test. Come on, internet. Unit test. And then the big picture, integration test. Yeehaw. Perfect, right? Or my personal favorite, production. There. And then, look, it opened, right? This is your system, right? That has all the tests green, all the unit tests green, but then production goes bananas. So,
testing your code. In this video specifically,
YouTube is trying to tell me more. Actual behavior of A. What can happen with you when you play a lot of mocks? You can face a mismatch between what A actually behaves like and what you programmed the mock of A to behaving when integrated with by others. So inside the unit test, you might have a mismatch in there. You might have a query that you mistype. Not bad syntax, but semantics, bad semantics, right? You might have some framework magic that fails to work. For example, some security that never works. Maybe you call the transactional method within the same class and proxies don't work. Perhaps you've played the cacheable, but then the cache key is wrong. All of these are incidents in my customers. I've seen problems like this in the groups I have, right? Or maybe you've misconfigured the way you connect to Rabbit, or the retry, or bulkhead, or the resilience thing. Do you test your rate limiter? You should. Right? So how do you test that? Of course, with an integration test. So these things above we're going to address, but what's really nasty is that in microservices, one big source of pain is APIs you consume that betray you, that broke their contract, that give you different results than they promised to give you. How do we handle that? And I'm going to try to address all of this. So, the challenges that an integration test will have. There will be coupled tests influencing each other. There will be tests that break for real random reasons, apparently. There will be slower tests, right? Tests that force us to learn much more of our functionality as once, because we have to traverse a long path. And of course, there will be some investment required from the company, from the team, into building tools, into building maybe some helper libraries, maybe even some training for the groups, and to see how do we use this integration, how do we survive writing more integration tests. It's time for a little bit of code. Imagine we have this production class to start with. This little function we're going to test. When we create a product, we receive a DTO, and then we check with another API to see whether this product is safe to send by passing in the stock keeping unit, the barcode, to that other system. It returns this adapter that we are looking at here, this little class. It returns me just true or false. If it's not safe, throw. All right? And then some ifs and some logic, and then at the end, some save in the repository. Okay? So super simple, and this is tested already with Mockito, with a unit test. What I want to do with you today is to migrate this towards an integration test. So, with the Mockito, what do I have to do? Let me read the tests first. The first test, the safety client over here is returning me here false. It means this call returned false. This call returned false. It means the exception popped up, and I've asserted that over here. Right? Let me run the test in the meantime. The next test below there says if the safety client is safe returns true. Okay, so if this thing over here returns true, then the if does not happen, and I get to run the rest of the code. And then some kung fu here that I'm going to replace very soon with integration test. So this is a test playing Mockito on a logic. The ones that we write as a reflex, the ones that we don't have when we submit the pull request, your pull request gets rejected. We have to have these. So what am I saying to move towards? Spring Boot test. And I want to boot up a database in memory, active profiles, dbman. A good friend of mine, H2. Then the repository, since I have a real database over there, I can just inject. The safety client that is connecting to the outside world, for now, I will keep a mock and replace the real bean with a mock bean. The service that I want to test, I will just auto-wire from the container. And the capture, I won't need that kind of magic. So notice that this is still a mock added to the application that starts up for tests and replaced, and I can program the behavior of that bean. Then later over here, when I want to retrieve the product that is saved in the database, I don't need to use some capture thingy. Instead, I can just say product repository, actually that's repo, dot find by name the product name that I've used before, right? And that gives me the product out. Good. I don't need this kind of magic with mocks. As well, I can't do a repo save when then return because that's no longer a mock. So you see, this line in particular had to return a product with a given ID, emulating the behavior of the library. When you call save, it returns you back a product with an assigned ID. I don't need to have this detail of implementation of that library inside my test anymore. The test gets closer to the intended behavior, right? So right now I've started Spring. You can see a banner over there, right? The banner. Oh, the banner. Oh, the banner. This banner is going to cost you. The more banner you see in your build on your CI, the more time you spend. I hope you were aware of this. Every banner costs you between 10 and 60 seconds in build time. So right now, go back to your build pipeline, scan, search unless you disabled the banner, of course. Why would you do that? Anyway, so the banners means you lose time. Okay, good. So now we have a database started in memory in which we can persist stuff, right? But you see, this is H2. H2 is no longer fashionable, some companies say, and I've heard teams and CTOs forbidding H2 in their environments. What did they use instead? Testcontainers every time. So instead of this, the first move that I'm going to do, I'm going to inherit, first of all, from an integration test class that I have somewhere in this project next to me, right? I've moved the annotations in there, nothing fancy, but then I'm going to open the door to Testcontainers. Now, I'm not supposed to enter very much in Testcontainers. I'm just going to tell you what it does. It spins off a Docker container in a local Docker daemon, and the unit tests are in charge to spin it off and then tear it down at the end automatically. What happens right now is that my tests are connecting to a Postgres behind. I'm no longer talking to a H2 in memory. I'm talking to the real database, the real one. You can tell that when you see int 8 here, if that makes any sense. But the point is, I'm using a different database, right? Okay, so now I'm using the real DB. I can use native queries. I can feel just like in production, right? Right, what's the next move? Well, I still have a mock of an API call outside. The next thing that I want to take down, and we always do this, we start with the database because the database is private to our application. It's a special kind of relationship between me and my database. There's a special kind of relationship. It's me and her. Right? It's a different kind of relationship than between me and some API I call outside. It's a different kind of beast, especially if the API I'm calling belongs to a different team, right? So next level to approach reality would be to give up on using this mock bean and not program what the adapter would return, but instead play the real adapter to check for bugs in that implementation also. Is the URL correct? Is the interpretation of the result? Is the parsing of the JSON correct? And so on and so on. So to play this also, I'm going to take down the mock bean and I'm going to replace this with a stub. Which is a Wiremock thing. I'm gonna call my friend Wiremock to the party over here. I'm gonna say auto-configure Wiremock. Thank you. Give it a random port so that it doesn't collide with other running servers on the same test, on the same machine perhaps. And then I'm gonna have to activate the profile called Wiremock. Why? Because that profile is gonna pick up a file here, Wiremock, which is configuring the correct URL to point to the newly started server in memory. So that will make my test fire against a locally started HTTP server running on a random port. Good. Now, I can use Wiremock programmatic configuration like this, right? Very, very easy. And I can just say here the URL I expect to receive as a Wiremock SKU unsafe. Where does this come from? It comes from the actual test below. You can see below the SKU unsafe is the input I gave to the tested code, and then to this. And then this is expected by the Wiremock to return this particular JSON. Therefore, I don't need to program the mock anymore. I will leave the adapter do the actual call. The same here. But this time, this has to return a true. Let's see how that works. Well, I need to stay here safe. And, of course, change the SKU, to the parameter to a different kind of ID. And that will fire up a Wiremock and will target my application towards that fake in there. Now, one important thing to notice is that the two stubbings could coexist. What does that mean? It means I was able to write the programming of Wiremock in such a way that both of them could be registered. Whenever you find that, there is an idea you can take instead. Instead of hard coding this into your Java code, you could use files. So therefore, I can have these two files which tell the Wiremock what to respond. I can put them in the mappings, and we're good to go. But who knew this already? Who knew the Wiremock thing already? Oh. So it wasn't in vain, like 30% of you knew this. This is like fundamental for testing API calls to others. You don't want them to really call the other systems. That will make your test very unreliable, right? So right now, because the SKU unsafe here matches the URL expected by the Wiremock, the response below you figure out. It's not hard, right? You can do more kung fu here, like matching JSON paths, all sort of Gundam style in there, like. Yeah, but it exceeds the purpose of this. Read more if you want. So I have this Wiremock, and I'm getting closer and closer to reality. Now, let's see how far we got. And also, let's enjoy the benefits. Look, if I start Spring, I am now able to test magic features of Spring. Let me show you a magic feature of Spring. Anyone knew about these things? Created date, created time, very few. What's this? It's a magic that tells Hibernate to fill up the current date when you create it, and then the security principal username when you create it, automatically. Taking from the security context, from the token, from whatever you authenticated this request, it will pick up the username from there, the principal name. Good. And these can now be asserted, because they work. They work since Spring does all its magic together with Hibernate. So you see, magic features. We see magic features that we can bring under test, and also we saw that we don't have to emulate the behavior of the repo save. I don't have to emulate the behavior of the library. I can play the actual library. However, I have a problem. Let's see what we have here. Click to see difference. Oh, the username. I don't have anyone logged in for this request. No problem. With mock user. With mock user. With the username named John Doe. I just logged in a user. I faked a principal logged in. And that username from there is going to be set here by Spring. Magic, okay? Okay, fun, right? You should probably read more about some of these topics if you are interested. But then let's do something fun. Let's run with coverage. I hope you all know what that is. You should run it weekly, like to check. Because this is what we do, right? We write the feature and then, hey, test. And you go to testing and you want to check that you've really covered everything. And one basic way to do that is run with coverage, which will show you that the code we thought we tested, let me just go there, create a product test and create product, good. Can I write it, run in one more? Run with coverage. So the run with coverage is going to see where exactly you've been with your test, if they work, right? And if we found, hey, but what is this? What is this?
Ooh, what does this button do? Please, do not push the button. You have no idea.
I didn't test this line. Oh my God, what should I do? I should test it, of course. And like a good professional, I'm going to do. No, don't laugh yet. Laugh now. I'm going to. Oh yeah, with the mouse, like a professional. Copy. Excellent. You should feel pain when you copy stuff, right? So what should I name this test like? Like default to uncategorized for a missing category, business term. And then I will have to pass inside a null as a category. And then later on, I want to expect that what's saved in the database is uncategorized. The rest I don't need, I've already tested. I don't need to overlap it again, right? So I'm gonna just clean to leave exactly what I need for me. And I'm gonna run again the test, hoping that that line will gonna get green. Oh, the pressure is killing me. Why do I have to wait so long? Oh, I have a problem. I have a problem. I have a failed bug. And like a good citizen, I want to debug the failure. Right-click, run, to see what's wrong with the test. And then, I'm a good citizen. I want to fix bugs, fix broken test, and then... What do you mean green? It was red. What's wrong with you? Remember test coupling? Let's see again. When you run a test with its friends, it fails. When you run it alone, it passes. That's a sign that there is coupling between these tests of yours. Some of the tests above leaves garbage in the database, which breaks the following test. Probably you knew that already. You've seen that. But it's much more fun when you have 100 test classes, each with 20 tests, and one of the tests in the one class over there breaks another test in another package 1,000 tests later. It's very fun. OK. So how do we fix it? We have a number of solutions to this problem. The classical one that you should all think of is to clean up after you, right? To say, hey, let's do repo.delete all. That's the first thing. It works in everything. It works in Cassandra, in Mongo, in GPA, everywhere works, right? But then you're going to have still a problem. What if someone leaves garbage in your database before you enter the first test? Then the first test. So how to fix this? You clean before and after. Just to be safe, just before and after. Some say, no, everyone should clean after them, but do you trust your colleagues that much? I mean, let's be super safe, clean before and after. That's one solution, OK? That should make the tests pass together. And if I run all the tests with coverage, I should see the entire method going green. Now, this is one solution. There are 3 or 4 more other solutions. This is the widely applicable for everything, right? The other solutions I want to quickly demonstrate is this out, and the other solution, if you are facing a big SQL database, you need some help. Sukili cleanup. Good. And you can bring a friend here. You can do. I've seen someone doing some reflection in Postgres to find out table names and truncating all the tables. Hiya! Right? Do your stuff, right? Reset the sequences. Do whatever. If you inherited a large database, that's your friend. However, one of my favorites is transactional. If you make your tests become transactional, every test is because I'm using a relational database here still, right? So in that case, after every test, the testing will gonna issue a rollback. So every test cleans after itself, saying at the end, rollback. Done. It's too good to be true. You don't need to worry about anything. Anything you insert in the before you inherited, everything gets wiped out at the end, but it doesn't come for free. There are some quirks in there. There will be a link in the slides telling you more dark secrets about what happens. But we've seen test coupling. And since we have the code in front of us, I want to demonstrate one more feature of Spring. Look. When you start Spring, I told you to look out for banners. Every banner you see is going to cost you time, OK? Right. Now, the question is, right now, when I run a single test, how many banners do I see? I see 2 of them. I'll tell you why 2. Because the first attempt to start Spring failed because there are no test containers started, so it has to restart. In detail of Spring startup. But my question is, if I had 2 with one class, if I copy-paste the class and create an identical copy, how many times do you think Spring will have to start? Will Spring start for every class? I mean, I know what most of you are thinking because I do also all these workshops. The general belief is that, yes, it will start for every class. So let me run the package with both classes together. Two separate test classes, right? Two separate. If you have been to the Java 21 presentation just before, you saw their Spring Boot startup time. Unfortunately, there was no Graal equivalent on the. The point is here that Spring is slow to start. Spring is historically pretty slow to start. Unless you're using some ahead of time compilation and you spend 10 minutes building the application, Spring is slow to start. If it's slow to start, they did their best to reuse the context they started for testing. So therefore, even if you have two separate test classes, we still have just two Spring. The first one that's failed for test containers, and the shared test context used by both test classes. This is wild. You have the same Spring instance used for subsequent testing test classes. So let's see. Let's debate more. Test coupling. We've seen test coupling, and the feeling is that you write, you see a failed test, you pick it up to run it alone, and it turns green. It can get even more tricky. You can add your new test over here and cause another later test to break. Of course, you can imagine. Because if they are coupled to each other, they are influencing. These are among the pains. The first things you're going to notice when you switch to integration tests. This means test coupling. And this is accidental, because I did not plan for it. It just slipped through my finger, and one row from the first came to the second, all right? And in the database. But it can happen also in queues. If you start up a Docker and you put a rabbit in a Docker, that rabbit might have pending messages, and you need to drain the queues, or clear the caches, or reset the state if you have in singletons. But that's accidental accidental test coupling. There are other scenarios out there, I call them user journeys, in which you want to chain multiple interactions with the API that you are developing. I'm going to show you a simple example right straight now, although it might be a bit overwhelming, but here. Hey, create the product. Hey, search the product, with, of course, the same name. Hey, then once you get the result, get the ID and fire a third call to get product details. You see, a user journey, like an interaction with some client that assumes that you preserve state between the interactions. This is the end of the food chain, one of the most complex and most fragile and brittle tests you can ever write. Imperative to have these for the checkout flow, for example, to make sure the whole thing works. We are at the top of the pyramid right now, right? So very hard to maintain, but that's a user journey which assumes that the system preserves state between calls. That's a prerequisite in there. Good. And we cleaned up the database with different techniques. Manual deletion, SQL, Sukili script, transactional on the test class that rolled back at the end of each test. And there are some links here. There is a link in the bottom with some quirks of if you're using transactional. Reboot Spring. That's fun. Let's do dirty context. Why not? Let's nuke Spring. If you ever use dirty context in your application, folks, even if you are not using Spring, you will find these concepts copy-pasted in Quarkus, in Microservices, any framework in the backend. They are going to do something similar eventually, as they copy more from Spring, right? So dirty context blows up the Spring context and forces it to restart. Losing time on Jenkins, do not on the pipeline. Don't push this. You will harm your colleagues. Okay. Now, there is another approach to integration testing that does not expect the database to be empty at the beginning. I may have rushed too much. Folks, did you understand why the test failed in here? I do find by name twice here and there, and the create product inserted twice the same product with the same freaking name in the database. You know how we could fix the issue without having to clean up? Put here 2.
Isn't that cute?
But that's a technique, actually. If you read into, that's a technique. It's called test data slices. Test data slices means you don't assume the database is empty, but you create your own stuff, right? So, for example, you save a supplier, and the ID that got created you use to create the product, right? You create the product, and with that product ID, you place an order. There you go. Or you generate a random thing, you use it as a name of a user, and then you search for that random user. You see, it's just like you see only your own data in the data store. Whatever was there, you don't care. You have your own slice of data. And you can use this technique for ecosystem-wide testing. Go to first microservice, go to second microservice, go to third microservice, every time chaining IDs to one another. Okay? Fun. And to increase the heat a bit, these tests could be run in parallel. You don't care what's in the database. They will each see their own. Okay. What database to use? We used H2 historically, but now I told you some companies completely rejected, banned it, and said only Testcontainers. Testcontainers using our own variation of the standard Docker image, with all our quirks and hacks and operation dynatrace thingies put inside, exactly like in production. Right? That allows you to run your incremental scripts. Let me show you that. That's so fun. So few teams unit test their integration, their migration scripts. What if I mistyped the table name? I put an S in addition here. Do you have a test that fails because of that? You do have incremental scripts, I assume. Spring fails to start saying, hey, where is the supplier table? I know about suppliers, you see? I caught the bug in incremental scripts. So you can run the scripts, and you can use those dark features you wanted from your database, like PL Sukili or convert or connect by. These things suddenly work. I mean, like native SQL hardcore things specific to your particular database. Okay. Right. Now, flaky tests. That's a very nasty beast. The build is failed. It's that test again. I don't know. It works on my machine. Run it again. 20 minutes later. What? It passed this time. Told ya. So, what to do? Whatever you do, don't let the test on Jenkins until you fix it. Because that will develop in a team a culture of tests often fail. You know that? If the build is always broken, 10 years, 6 months from now, you're going to be full of bugs. Because no one will going to care. Yeah? That's basically a DevOps principle. Do not let the build fail more than 15 minutes. If you are unable to fix the pipeline in 15 minutes, undo your commit with another commit, fix it, and then humbly go back and try again. Right? I would love to see Jenkins fighting back.
Just got notification that
The
someone
broke the build. Someone broke the build. And then what happens? Jenkins fires. Right? I would love to have that. It's hard with remote office and it's complicated, but who knows? So if it's a flaky test that either fails or passes, one core reason for that to happen is when you call an external system, don't do that. If they're out of your control, don't do that. Parenthesis, I see some teams managing multiple microservices within the same team. If that happens, you might consider starting the 3 microservices you own together. Like a bit of a gray area. In general, you should not rely on what another system is doing, right? But that can also happen, and we can fix it if we are talking about some work happening in another thread. And I want to show you one example of a flaky test that works on my machine, but not on yours. Which is this. I call it black test because it's a black box test. This one starts up a queue in memory, a Kafka in memory, and sends a message on a queue. And that's it. Puts a message on the queue and sleeps for 120 milliseconds. What happens exactly? Let me show you the code that I'm testing over here. Some place in my application, there is a class which listens to that topic. So when I send to supplier created event, my message gets into here. That thing over here is going to save the supplier into the database. You see that, right? Okay. So then I wait for a bit, and then I look in the database to find the row that got inserted. I do supplier repo find by name by that name in the database. And if my machine is not as powerful as yours, then these milliseconds you've put in on Git are not going to be enough for me. Anyone heard of Selenium before? Selenium? Then you know what I mean. Let's sleep for a bit until the results are in the page. No shit. How much? I don't know. Put more, double the number. How do you do it? Fibonacci? What do you do? How do you... Anyway, that's why we are moving towards other frameworks. Cypress I can do event-based, but that's the problem. How can we work this out in particular here? Well, the standard in the industry today is called awaitility, awaitility.await, and I want to await at most. How much do I ever allow this test to run? Well, I don't know, 1 second max. And then every let's say milliseconds, you can see me, I'm not a very patient guy, 20 milliseconds. I'm gonna say something with asserted. Until asserted, and then run this assertion inside that. The fun about the until asserted is that if the test fails, it's going to output the failure that was recorded, right? There are other forms of writing of using awaitility, but that's something the best, right? So that will keep polling. Are you done? Are you done? Are you done? Until you're done, right? So the test takes the least amount of seconds of time possible, and if that breaks over here, it's going to output the error. Let's save time. I don't want to demonstrate. The code is on Git. The Git is on the first slide. I'm going to share it on Twitter afterwards. All right? So that's one thing. And that kind of test is not healthy. I mean, I'm not sure about you guys, but I feel awkward. I have to wait until the planets align. It's hard to grasp. And if you want to put more assertions into here, what would you do? Would you pass a lambda? I bet you're going to extract this into a function. But that function is going to take a lambda. This thing, it's ugly. It gets just ugly, right? There are more issues to this. Exceptions, you don't see exceptions in here. If there is an error on that code, you don't see in the listener, you can't catch exception. You can't do assert thrown by because you don't call the production, you see? Facing asynchronicity is really nasty. So I want to avoid that. And let me show you a way to avoid it. I'm gonna use here some very dark magic called spy-bean. What the heck is a spy bean, you could ask at this point? This test over here, look at it, is just sending a message on the topic, and then, because this is a spy bean, blocks the call from entering the body of the method, saying, okay, I'm enough if you were called on message method within 1 second. This is our friend Mockito, no one else. So I'm going to block the processing of the method just to prove that the queue is correctly configured, all right? If I want to check acknowledgement retries, I'm going to throw an exception from that. I'm going to do when on message is called, throw exception to Kafka to check just the Kafka interaction, right? I'm going to write the test only on that because asynchronicity is so painful. And I'm going to write another test for the actual logic in which I'm going to freaking call the method. Call. Exceptions work. No asynchronicity. Peace and harmony. You see my point? So handle asynchronicity with great care. Avoid it if possible. Right? There are other hacks here, like turning your executors into synchronous executors to just disable asynchronicity for tests. Right? Because asynchronicity is that hard. Okay? And we can block the test. That's what we did in the black test originally here. Where are you? Here in the code here, we blocked the original test with block test, with black test by saying, not this one, but this timeout. I actually didn't know about this since recently. You can tell Mockito to wait for a call to happen. Who knew that? Huh? We blocked the JUnit thread in here, right? Or we could also sometimes, depending on the technologies you're using, you might be able to register a callback when the work is done. From the callback, you can unblock the test using some completable kung fu. Just avoid the latch. Anyway, it's an old technique. And what we saw in code was polling for the effect. Now, microservices very often play with queues because they are resilient, robust, blah, blah, blah. But if you play queues, you're going to face this issue. Right? How do I know when the listener really did the job? Ideally, you could be able to maybe send another message in return, or somehow, because the question is, how would your real client gonna find out you did it? You did the job. How will your end client? Would you send another event, or would you just put stuff in the database? If we put stuff in the database, can I call a get? Is your client supposed to do a get after that? So think about how the contract of your system is going to look, not just that function or that class. How is your microservice going to behave? Now, one topic that integration tests are really having a hard time is speed. And imagine you commute back to home, right? Having a great time in the train, sleeping, build failed. Or maybe you took the bike. Build failed. Or maybe you just went back home. Build failed. How does that feel? I mean, I really love this picture. I mean, I'm going back home, build failed. Amazing. What would you do? So the test should finish in 10, 12 minutes, not more than that. Right? So what do we do to improve the performance? The first thing to think of is Spring start slow. The container, the application. Don't start up more instances than you need. As a matter of fact, I wrote my own little JUnit extension that is able to measure how many times you started Spring. It prints at the end of all the test suite. It says, hey, I've started 2 Spring contexts, and for the 10 seconds that your test took to run, 9 seconds, 0.7 were spent starting Spring. It's not perfect, you can improve it, I'm sure. But the point is, it monitors how many Spring contexts you booted up. You should not have 100 contexts started in a build, okay? Because it wastes time. So you need to recycle the same context, and Spring will do that if and only if your test classes are using the same kind of configuration for your test classes. So if you use a different mock bin over there, that will be a different context. It cannot reuse your original context. If you change the profiles, if you change the properties, it will not work, okay? So you need to reduce the unique combinations of these. There are some logging that can help you along the way. And, one warning. That was so fun. I did a consultancy several weeks ago, and it was in person. And when I came to the room, they were all waiting for me, smiling. Like, I sat down, and why are you smiling? We have a bug for you. It took us 2 weeks to find, and we are curious how much it takes you to find. And they literally gave me the bug. Play. Round 1. It took me a while, but eventually we realized that there were 2 instances of their application running at the same time. You don't have this in production. In production, there's a single Spring context. We can have as much as 32 Spring instances in the tests. And guess what? One of the Spring instances was stealing a message from a queue that another instance was listening to. They were competing, just like you would load balance the application. How creepy is that? Right? You send a message, boom, they stole it. What a second, right? Very evil scenario. So be careful that you can have multiple instances started at the same time, in parallel, right? How do you speed up Spring Boot? The first thing, some flags, they won't help a lot, but the next thing, reusing Spring context, making sure you reuse the Testcontainers and Wiremocks. If you are not sure whether you do that or not, you can profile the execution of your unit test to see where your time is spent. Okay, very easy, you can pinpoint exactly toward the problem. Okay, I retract. It's not very easy, but you can have some sensible clue where you lose your time. You can start a part of Spring, or if anything else fails, you can defer the slow test to run during the night. Not every commit, just when full moon, Sunday night, I don't know, during the night, right? In order to have the feedback fast to the developer and not have the developer fixing the bug in the boat. Okay, because that's what he should do. Do you think he has an anchor? I don't really think so. So he's gonna stray away while fixing the bug because he has to fix the bug in 15 minutes. Otherwise, you need to undo the commit. Right. So the next thing you could try is to play multi-threading. Start tests in multiple threads. Good luck with that. Things can happen. You will get this idea once or twice, and then that's it. You can see some remarkable decrease in runtime, but there is some risk over there with race bugs, like concurrency issues between the different tests that you have, like mock beans racing on the stubs you taught them to do, files or message queues, database fighting at the same time, extremely, extremely, extremely heavy. So be very careful when you throw multi-threading at the problem, because things will not be reproducible anymore, right? And probably we should have a master switch to turn it off, to debug an issue, and then turn it on back on. It's really, really nasty. I've done some debugging like that. Another thing that stops most teams to go into more integration tests is the amount of cognitive load they require. You need to understand more of your flow, much more than before. And so what some people don't realize is that if you want to drill a hole in the seaside, you would use one tool. If you want to plant a tree, you would use a shovel. If you want to build a bridge, you will use a different kind of technique. You can't use the same technique to go in the checkout flow containing 2,000 lines of logic as you do when you target a method of 20 lines. It's not reasonable to do that. So you will need tools. You will start building private functions. Create some object mother to give you standard versions of objects that you then tweak. And maybe you can go as far as writing your own DSL. And there is this guy, I'm not sure if you know this guy, who several years ago wrote a unit test, which is public. And his test looks like this. Reads like a prose. Would you suspect that there are 18 network calls happening under the hood? That is actually targeting his own API with this? These are wrappers over the REST APIs of his application. I did the same in some example over here. Just the time is kind of pressing. I'm not sure how deep we can go with this. But have a look here. The user journey itself. Create product over here is calling create product below, right there, which is targeting the mock MVC to fire the actual call, right? And maybe then search product, create product. All of them are calling the API of my system, and they provide like a domain-specific language, like a wrapper over my endpoints to be able to build more elaborate flows and still make sense of the test, okay? Of course, any framework you build runs the risk of having bugs in the framework. How would that be? I have a bug in the testing framework. It's what? Did you test your testing framework? You should not go that far. It should be simple enough not to require its own test. That's kind of the rule of thumb. Anyway, it's an interesting question, when to build a testing framework and when not to. If you have to go through a flow 10 times, you don't need a testing framework. If you need to go through a checkout flow that is very long, you need seven helper classes to get you through, right? Now, when you look at this integration, when you look at testing in general, you can classify tests in reproducible or flaky, in fast or slow, and we mentioned what to do about each of them. And also, regarding scope, they can be unit test. And remember the discussion yesterday, they can be solitary or social. Or integration tests. And integration tests can also be gray box and black box. What does that mean? Gray box integration tests can access the database. The database. A black box test doesn't. The black box test is just going to fire API calls to get and post and everything, right? So, of course, the lower you go, the more complexities to write the code and the more robust and significant the test will become. One point, very fast, contract mismatch. What do you do with that? There is the first responsibility of me as a provider of an API is not to break my API by mistake. You guys can read this. In my class path, there is a JSON. I boot up the application. I get to v3 API docs. I get the actual JSON and compare to the expected JSON. You see what this does? If someone breaks the API that I expose, the test fails. It's an approval test, basically. It makes sure that the current contract matches this JSON that I've saved yesterday on my Git. It prevents me from changing my API by mistake, but that's not the only issue. The issue is, how do you know when they change their contract? There are two solutions for this, Spring Cloud Contract and Pact. Both of them end up failing a build somewhere when the contract offered by the provider does not match the contract offered by the consumer. It's just like proving the mock behaves itself by doing some kung fu and getting the contract from there over there and crashing the build of one of those if the contracts start to have mismatches between, okay? So, as a conclusion, you start off by writing API level tests. Struggle as much as you can there, and you fall back to unit tests when facing too much complexity. Now, if you are not green, but more of a brown, You can convert greenfield, brownfield. You can convert the existing mock-based tests in more integration tests like we played here. There is more to it, much more to it, right? But do it in baby steps and measure the complexity you add, both intrinsic and both related to the functionality you are trying to cover and to the techniques that are required, like active profiles, test containers, kung fu, cleaning, all this. Measure the benefit. Does it matter the risk you cover, the added complexity or not? Okay. Go longer flows, include database, include mock responses from them, involve queues in memory or in Dockers, test the magic of the frameworks, and maybe you even consider booting up your application in a dedicated Docker. I find this a bit maybe too much for most cases, but that's an option. So, the challenges of integration tests: isolate your tests by cleaning up after you. Make sure you handle asynchronicity carefully. Speed up, tune up to see less banners, less startup of expensive resources, and maybe build up a DSL for yourself to make your tests more expressive. And with that, I think I'm out of time, and I thank you all. And I will wait for your questions over here because the time is out. So thank you very much.